here's the scenario. We have a web server that's hosted on a Kubernetes cluster, and you are on the web server, or you're on the website, and you find a pretty damning SSRF bug, a server-side request forgery, that allows you to see what's on the server. You query some endpoints that are common in Kubernetes clusters, and all of a sudden you're looking at cluster secrets. You use those secrets to escalate within the cluster, and eventually you achieve persistent access. And it's basically cluster down, cluster takeover. That is a scenario that we're going through today. Let's get started. Okay, so first we're going to launch our Ansible playbook. Using this command right here, Ansible-playbook, and then the name of the scenario, SSH, oh, whoops, that is a wrong scenario. No, it's SSRF to insecure port.yaml. All right, and here we are. So as we can see, the cluster IP address is 172.18.0.2, but we're going to do things a little bit different this time, as we're meant to. So if you go over to the repo for Kube Security Lab, and you're at scenario setup / SSRF to insecure port, basically the scenario setup for this scenario, you see that he basically wants us to start at a web server. In this case, it's hosted by localhost, but if this was a real scenario, it would just be a website, right? So we are going to do that and move on. I see. Okay, so it takes a little while to warm up, I guess. Maybe wait like 4 minutes before hopping into this scenario. Okay, so after a bit of debugging, I realized that it just takes a few minutes for the web server to start up. So when you're doing this scenario yourself, just make sure you wait like 4 minutes before attempting to start the scenario. So yeah, as we see in the instructions, we go to localhost, which is usually 127.0.0.1, and port 4567 on localhost. So localhost colon 4567, enter, and this is the web server hosted on Kubernetes. Now, it seems to be like some kind of administrative function called SSRF tester. Would you see something like this in the wild? Probably not. But just think of this as like you found a server-side request forgery, and now you're making a GET request. So this is an SSRF tester, right? So the URL that we are entering here actually gets executed on the server side. So while this SSRF tester is exposed through port 4567, the URL that we want to get is actually going to be port 8080, because we're making an HTTPS request to, or sorry, an HTTP request to the API. So here we are. This endpoint is correct, /API/version1/secrets. That's how it should be. And we're still shooting for localhost, but we want to do colon port 8080. Nope, not quite. Missing a slash there. There we go. So here we have all the secrets of the cluster. It's kind of jumbly and messy. And I kind of tried to throw this through a JSON beautifier earlier, but there was some stuff that, like, just, I don't know, a little error somewhere, and I didn't feel like debugging. But basically, what we want is to find a service account that has some permissions that are going to let us elevate privileges on the cluster, right? So let's see how we can search through this a little bit better. I'm going to do Control F/secret. And here we see default token, attach, detach controller token. There's lots of tokens. Each token has different permissions, right? Now, it's going to take some getting used to knowing like which service account token has which permissions, and, you know, as an attacker, basically, which is good for elevating privileges, right? One that is always good is cluster role aggregation controller, as we see here, because one, it's tied to the kube system namespace, as we can see here, and two, if we can, since it's in charge of like changing cluster roles, it's in charge of permissions basically for the whole cluster. Using this, we can elevate our own privileges. I forget the name of the specific permission that it has that lets us do this, but you'll see in a second. So yeah, here we have this. We're just gonna carefully copy. This is ca.crt. I'm just gonna scroll back to confirm that I grabbed the right one. Yeah, that looks about right. Okay, now I'm gonna hop over to CyberChef to decode this base64. Take that out, put this in, and yes, decoded from base64, we get what looks like a service account token. So that's good. So we're going to copy this, and we can go back to our scenario. So here I've already started up the client container. Whoops. This is the container that we attack our scenario cluster from. Yeah. So I'm going to save the token to a variable called token. And I don't know if I've already saved. Yeah, no, I don't. Okay, I believe our target IP address is 172.18.0.2. Let's see if that's right. Yeah, it is. Okay, nice. And here we see the web server that we were just exploiting on port 4567. Again, the service names for Kubernetes clusters, I don't know why, they're usually wrong when it comes to Nmap, but just know the known ports and you should be good. And when you see a mysterious port, just try stuff. Okay, so we have a token and we're going to do stuff with it. So over here under useful commands in our cheat sheet, we see RCE with compromised service account token. And we're going to use that command. Replace command with auth cani -- list. Replace namespace with cube system, because we already know that this service account is tied to that namespace and it's the namespace that we want anyways. Replace token with our token. And port 6443, that's the API server. And our cluster at 172.18.0.2. So this should run nice. Okay, so let's see what we got. Now, again, this was the cluster role aggregation service account. Now, what's interesting about it is it has this permission right here, escalate. We can literally escalate our privileges. And I'm going to show you how in just a second. So over in the cheat sheet, I actually have some commands for how to abuse this specific permission. Abuse, escalate service account permissions. There we go. So first what we want to do is we want to see what cluster roles we have here. Specify host and port. My bad, we need to have all of that other stuff as well. So we're basically just changing the command here to get cluster roles to ours. There we go. So here are all the cluster roles. And what is a cluster role? It's basically just like a role that spans the whole cluster. That's good because you know it's included in the whole cluster, the control plane. So if we can edit some cluster roles to be like overly permissive and we can steal their service account token, then we are effectively, I mean, we can do anything. So we have a service account token for the cluster role aggregation controller. Here, what we're literally doing is we're changing the permissions for that service account. We can do that because of the escalate permission. So we're going to copy the name of that here. And now we're going to use the edit cluster role commands. Just had to look at the cheat sheet for a second. Edit cluster role, and then the name of our cluster role, which we have copied. Enter. And here we are. Please edit the object below, yada, yada, yada. Okay, so here you can literally see the permissions that we saw when we used our command auth cani -- list. Escalate get list for resource cluster roles. Now, what do we want to replace this with, right? Basically just star -- star. We have to put it in quotes here, so star -- star in single quotes. And then we're going to remove all these verbs and just put star -- star. So now, oh, also API groups. We don't want to be just in that one. We want to be in all of them. So star -- star here as well. So now we have all permissions for all resources in all API groups. We just got to save. Let's see. What text editor is this? Oh, I think this is VI. So colon WQ for write quit. And there we go. And why not just check it to see if our changes have been saved. So auth cani -- list, and boom, we can do everything everywhere. This is good. So let's go for what we came here for. So we're gonna get pods in kube system. Wait. I think I messed something up in the cluster role. So it looks like when I put star -- star in the API group section, for some reason it basically, by removing this line, which was already there, I had access to this API group. Now I'm locked out. And I literally can't go back to edit the cluster role again because I've removed my own permissions. This is funny, but ultimately this is fine. We have other service accounts, guys. Okay, quite the blooper. So yeah, we're just gonna go back. We're gonna take a different service account. Let's see what we got here. Okay, so after an embarrassingly long time, I have found a service account token which can elevate our privileges. So here, service account token is daemon set controller token. So good to remember for next time. And yeah, it's quite permissive. Most importantly, what we're going to be doing with it is we're going to be using the pods create permission to create a pod on the create a pod that shoots a reverse shell back to us and allows us to steal stuff from the API server. So without further ado, let's get going. So in order to create our reverse shell pod, first we are going to go to the attacker manifests folder in Kube Security Lab for some helpful pod.yamls. So here we have the ncat reverse shell pod, very useful. We're going to copy it and go to nano. I'm just going to call this pod.yaml. Whoops, no nano here. vi pod.yaml. And now that that's copied, we are going to change the IP here with our IP that we want to catch the reverse shell at. So for that, I'm going to open up another shell, type if config, whoops. We need to go into our client container first. If config, and here we see 172.18.0.3. Now, choosing the right IP is kind of complicated here because we're not like using our computer, we're using like a Docker container. Yeah, the networking is different. But as long as you choose something that's similar to the IP for your cluster, you should be good. So our cluster that we're attacking is 172.18.0.4, I think. And so here we have almost everything the same. We know that that's the IP address that we want. Control-Shift-C. And we are going to paste this here. Nice. And we don't need to change anything else in this pod definition. So as you can see, what this reverse shell pod is going to do is it's going to mount itself in the /pki directory and then run bin/bash towards this IP and this port. So yeah, let's just, we hit escape, :WQ, whoops, escape for real this time, :WQ, which is right quit, saves and exits. And over on the left, we start our listener, NC for netcat-lvnp. Most importantly is the L here for listen, and then the port we want to listen on, which is 8989, because that's what we specified in our pod.yaml. And we are going to launch our pod, kubectl. Whoops, let's, yeah, we have all of our stuff here. We're just changing the command at the end. So create -f for file pod.yaml. Whoops, we have an error in the pod definition in line 11. Yeah, right here. Okay, should be good now. Execute that command again. Pod created. Okay, so here we're just going to be listening for it. It should reach out pretty soon. If you type ls and hit enter, then that command will actually execute when the reverse shell is caught. And that makes it a little easier to see. And there we are. So now on the API server, on the control plane node, we have a shell and we are mounted in the PKI directory. And that's awesome because that's where the certificate authority key is, and we can use that key to sign our own requests. And that means that we can come back here and steal whatever we want. So without further ado, let's cat PKI. You can see the mounted directory right here, /ca.key. And there you have it, folks. So yeah, this okay, so yeah, this scenario, I don't know, I like it. It's different because we don't start from a port scan, and it's kind of more realistic because usually I think in the wild you're not going to start by scanning a node. You're going to start by exploiting a service, right? And that's kind of what we did here. So yeah, hope you learned something. This stuff can be really overwhelming from like classic, I don't know, whatever your background is, as long as it's not Kubernetes. Um, there's a lot to kind of get into with Kubernetes specific stuff. But yeah, keep plugging and stay sharp. Have a good one.